Hello again, and welcome to this session. Hardware in loop. After completing model in loop and software in loop, next is hardware in loop. So, what is this hardware in loop? Hardware in loop in ADAS system refers to testing environment where real ADAS hardware components like cameras, radars, and electronic units are integrated into simulated environment to test their functionality under various driving scenarios without needing a physical world on the road, essentially allowing engineers to validate the system's performance in a controlled virtual setting. So, whichever component you want to test, whether it is sensor or radar or a camera, that original hardware will be uh, will be taken as it is, and then it will be tested in a simulated environment to see the correctness of that particular hardware. The hardware may be camera or radar or electronic control unit. Now, why exactly is this hardware in loop used? What is the purpose this hardware in loop? Challenge in automated driver assistance or autonomous drive functionality test is to add crucial components such as sensors and ECUs to model the in loop environment. So once the real hardware is combined with simulation, they form a closed loop. We are talking about hardware in loop test. Okay, I hope this explanation suffices. What exactly is this hardware in loop? Key aspects of hardware in loop ADAS system. First is simulated environment. A computer program creates a virtual world with realistic road conditions, traffic, weather, and other relevant factors, providing input to ADAS hardware. Okay, so this is the simulated environment. What are the real hardware components? The actual ADAS sensors, cameras and radars, and engine control, the electronic control units, the ADAS DCU, ADAS domain control unit, are connected to the simulation, allowing them to create simulated data and react as they would in real driving situation. Now, in this particular setup, the various scenarios are tested. Engineers can design diverse test cases, including emergency braking, lane departure warning, pedestrian detection, and different weather conditions to thoroughly evaluate the ADAS system's performance under various circumstances. So, once you have the actual hardware, you can test that hardware in the various simulated environments to check the correctness of that hardware. And as I said, hardware can be anything. It may be radar or a camera or a lidar or a sensor or the entire engine control electronic control unit in which software is already embedded. Now, typical components of hardware in loop ADAS setup are hill simulation software, software that generates the virtual driving environment and simulates sensor data. Next is real-time processor, a powerful computer that can process data and update the simulation at high speeds to mimic real-time driving conditions. Next is input-output interfaces, hardware that connects the simulated environment to the actual ADAS hardware, allowing data exchange. And next is data visualization tool, the tools to display the simulated environment and sensor data to monitor the system's behavior during testing. What is the hill overview? What are the core components? Core key components of the hill include the simulation environment, the real-time hardware, interfaces, as I already said. An integration process includes, it requires a structured integration of both software and hardware components, ensuring seamless communication and interaction during the testing. What you are seeing, the rig is the actual hill rig. This is the actual hardware in loop rig which engineers are going to use to simulate the hill environment. What are the benefits of hill? The most important benefit of hill is enhanced safety. Hill testing can run through hundreds or thousands of scenarios without the time and cost associated with conducting physical road tests. Hill testing can be run through hundreds and thousands of scenarios. This is something which I already touched upon. We can touch upon number of scenarios without actually running the vehicle in the road, which is prohibitively expensive. Hill testing can accommodate scenarios that would be too dangerous or impractical to test on the road. For example, you want to test uh, driving into a valley or driving at the edge of cliff. You fully know that this testing in the real life can be extremely dangerous, but it can be effortlessly replicated in a simulating environment. Hill tests are repeatable. The hill testing process is highly automated and can accommodate multi-threading so that multiple tests can occur at the same time, which speeds the development process. Hill supports a frequent software release process with known system behavior. While hill testing occurs later in development process than SIL testing, it still occurs within the parameters of CI/CD CT process, continuous integration, continuous development, continuous testing process, and enables developer to catch potential flaws before shipping the product to the OEM. So the mainly hill is used by tier 1 companies who supply the actual ECU to the OEM. Hill test results can be shared with development teams from OEMs and development teams from OEMs and third parties, which also speeds up development and contributes to quality, reliability, and safety. Hill process flow. What is the hill process flow? What is the process or order or chronological order of the flow of hill? First is initialization. Set up the simulation environment and hardware connection. This critical first step ensures that components are ready for testing. Next is execution. The run the simulations by feeding data through the hill setup, allowing the real-time processing and testing of system responses. So actual running the simulation, actually executing the simulation is the second part, which comprises of execution. And third is validation. Analyze the results against expected outcomes, against a benchmark outcome. And only when you have a benchmark outcome, can you compare the result and see the correctness of the outcome. And the validation step helps confirm if the system meets safety and performance standards. Hill test rig manufacturers. Now, as you see on the, you can see on the right side, that is the actual Hill setup, which comprises of a desktop and a computer or a laptop, and then which is connected to a Hill rig. So, who are the major Hill test rig manufacturers? One is Tata Elxsi, National Instruments, D-Space, Vector Informatic, Opal RT Technologies, Typhoon Hill, Speed Goat, Robert Bosch, Conrad Technologies, Hightex GmbH. Okay, this is not the exhaustive list. There may be other manufacturers also, but these are the major manufacturers or major players who are supplying to major OEMs and tier 1 companies. What are the major challenges in Hill? The major challenges in Hill are model accuracy. So, one major challenge is achieving high fidelity in simulation model. This goes back to the actual crux. This goes back to the actual core, whether simulation model is correct or not. Inaccurate models can lead to unreliable test results and may misguide development. Okay, this is the major challenge in Hill. Next is again integration complexity. Integrating different hardware and software components can be technically challenging and may require extensive calibration efforts. All right, integration. This is a very important thing and a very challenging thing. Next is scalability issues. As system becomes more complex, scaling Hill setups appropriately can be difficult, requiring additional resources and time. Now, see, most of the Hill setups they cover usually all the scenarios, but sometimes if the complexity crosses a certain limit, it can be very difficult to run the test case or develop the test case. So there are still some scalability issues that need to be sorted out by the Hill rig manufacturers. So, what is the future of Hill? The future of Hill is again shaped by trends such as AI, machine learning, and enhanced simulation capabilities. These innovations promise improved efficiency, accuracy in testing ADAS technologies. Okay, as you all know, AI is making foray and penetrating every area. So likewise, this is definitely going to enter the testing through testing of the hardware through Hill. So it's just matter of time. AI makes a full impact on Hill. Okay, so with this, I conclude this session on hardware in loop. Thank you.